Everyone for joining. You guys are some of the first, so we're going to do a different way of presenting today, and we're going to go in a little bit different format. So I appreciate you all taking the time to show up. One of the things we're going to go over here is sort of a two-stage thing. We are going to talk about machining, we're going to talk about the benefits, but we're going to talk about some examples and things that you may already have access to, or things that you can easily add to what you do today. So we're going to do a little bit of a start here. And as I get into this, I'm going to turn my camera off because I do have some videos and content. I don't want to compromise the bandwidth for my location. So let's go ahead and get started. Please bear with me just a little bit as we do some housekeeping work here in the front, and then we'll get into some samples. And at the end, we'll have some Q&A. So if you do have any questions, feel free to put them into the application, and then we'll try to go through them at the end. So with that, I'm going to turn off my camera, and then we will get started. Okay, so one of the things that seems to be a little bit of a mystery for people these days is the idea of SolidWorks having technology for manufacturing. And so the first part we're going to go through is I'm just going to give a little bit of an idea of what is available and out there and things that people may not know about. And then I'm going to give a little bit of a brief overview of each section, and then we'll get into what we're here to talk about today, which is machining. So when we start talking about our manufacturing portfolio, it's a lot deeper than what a lot of people realize. Obviously, we have SolidWorks Design. I believe that's why most people are here today, is because of SolidWorks Design. That's how I got started. Then we have our XDesign product, which is our browser-based CAD. And I can explain a few examples where that might be of a benefit to people outside of heavy engineering work that you're doing today with SolidWorks. CAM, which is the topic of this segment that we'll get into here in a little bit. But we also have things like robot programming. So let's say you want to offline robot program your arc welding cells, or you want to do pick and place or palletizing. We have a robot programmer standard and professional that has a couple different capabilities there. So if you're using pretty much any of the standard industrial robots out there today, we can connect that add-on, and you can take your designs and your work cells, then go through and do your program and put it out in the native robot programming language. Another area that's big these days is virtual factory. I want to optimize my factory. I want to see what the layout's going to be. I want to do what ifs. As we all know, when we start talking factories and components, the data sets become really, really large. We have a tool for that. We have Virtual Factory Standard and Professional. Standard gives you the ability to take your 2D, your 3D, maybe even a point cloud, put it all together, and then move things around like Legos in a really efficient fashion. Back in my day, that's where I started with the 3D Experience platform, was doing that on large factories. From there, we can go up and we can do those what if throughput analysis. Imagine your time study Excel spreadsheets brought to life and being able to interact with the geometry or data that you have. SolidWorks Inspection, that's been part of the portfolio for a really long time. It's an automated way to create your bubble drawings or your inspection sheets to be able to improve what that process is going to look like as it goes downstream into the manufacturing portfolio. MBD, that seems to have come around again as a little bit more of a hot topic. Can I put the annotations on my 3D model so when I share it with other people, I don't have to always have the drawing with it? I can give you the critical things that are important. It's all right there and to look at. Work instructions. We have a couple different options for that. Obviously, Composer, which has been part of our portfolio for a long time, gives you the ability to take any type of 3D model, being able to do those illustrations and what ifs. We also have some extended capability in the platform today, whether it's in a browser or in a native application, to be able to create those work instructions and then keep track of that and revision control it. Business process management is sort of a new thing, and it's a little bit of a niche area where I can write a rule or a process that then would create a user interface for people to work through. So imagine I go through, I design my product, but once I design my product, there's a series of steps that have to happen before it's released to the shop. And imagine those routers or work orders with the travelers that go in it. Through business process management, I can create a structured workflow that says, okay, do I have the engineering drawings? Do I have the spec sheets? Do I have the setup sheets? Do I have the piece of information that goes into the traveler? Do I have the components so when it goes to the shop, I have that one complete kit? We can create those business translations and transformation from that. And then the last three areas, we do have ERP and MES. Most people don't realize that through our Delmia Works group. And that gives you the ability to have manufacturing ERP specific to being able to manufacture goods and products. And that comes with some really powerful capabilities as far as capable to promise, scheduling, real-time process monitoring, warehouse management, advanced inspection. So if you're looking at bringing your house in order to be able to track and capture all that information, DomioWorks ERP MES might be a fit for you. And then the last two areas, 3D printing. Obviously, today we can't talk about manufacturing without also not talking about additive. We do have some tools in there that take the 3D model that you have and then be able to process it, build structures, create the best orientation, slice it, and prepare it to be able to go to your 3D printer. There's some advanced interrogation tools we have on top of that that work with our simulation tools if you want to go to the really high end and make sure the structure is going to support. And then the last area is reverse engineering. We have some tools that allow you to take a scan from an object that's a point cloud and turn those things back into surfaces and watertight geometry to then bring into SolidWorks and be able to do your what ifs or be able to make changes to it. So rather than dealing with a mesh model in SolidWorks or your traditional CAD tool you use, we have a step there where we can take that mesh, we can refine it, we can make it into more prismatic or just contoured surfaces that can then be referenced inside of your CAD tool. So with that, we're going to get to what we're actually here to talk about, which is machining. So when we start talking machining, we're going to talk about where we sit and then also what you may have today and may not know that you do have. So we have two groups of offerings, if you will. We have the top offering that started, almost 10 years ago now in SolidWorks 2017. So November of 2016, we launched SolidWorks CAM Standard and CAM Professional. And SolidWorks CAM Standard comes with any SolidWorks desktop seat that is on subscription. And we'll talk about what's in that in a little bit. And then there's an upgrade path to SolidWorks CAM Professional, which gives a few other extended capabilities like high-speed machining, 3+2, turning for single spindle, single turret, and we'll go through some of those examples. Last year, with the latest release that we have in, actually it was 2025, believe it or not, so a year now already, for anybody that has access to the 3D Experience platform through cloud services, you got access with that acquisition for ShopFloor Programmer. And ShopFloor Programmers kicks off our advanced manufacturing suite, which we'll talk about. But if you happen to have cloud services for your company or your installation, you now have the ability to also get ShopFloor Programmer. And that includes some extended capability like nesting, laser water jet plasma, manufacturability checker, full 3-axis capability. So there's a lot of things that people have access to that they may not know. And then beyond that, users can upgrade to our full suite of machining tools for Milling Pro, Turning Pro, Milturn Premium, and we'll go into what each one of those mean here in just a little bit. So if you weren't aware, you more than likely have access to one or two different offerings for foundational machining already today. It's just a matter of turning them on, getting some training, get a post processor, and away you go. So with that, we're going to jump into what would you get with SolidWorks CAM Standard. SolidWorks CAM Standard addresses really that prismatic, quick machining capability of, I have a part like you see on the screen, it has some counterbores, it has some pockets, it has a profile and a boss, and I just want to quickly put some toolpath on it. I want to go out and throw it on the machine and run it. Imagine like tooling and fixtures as an example. A lot of those parts end up being prismatic, assuming they're not 3D printed. And from that, I just need to really quickly go through and create some machining toolpaths. So we start talking about SolidWorks CAM Standard. One of the things that generally comes up that people know about it is we have the ability to do feature recognition. So imagine this part open in SolidWorks. We go to our tab over on the left. We run feature recognition, and it'll automatically go through and find basic prismatic features. You can see it found a face feature, a pocket feature, a counterboard, a hole, a slot, a curve, and it just put that geometry in so we can easily identify what's machinable. Now, keep in mind, feature recognition is looking at the geometry on the screen, not necessarily looking at the feature tree of how you designed it. So it gives some flexibility of no matter how you designed it, we're still going to look for basic prismatic geometry from that. From here, we have the ability to add or remove any piece of geometry we want, but it's a quick way to be able to go through and identify that geometry for us. The next area we have is rules-based standards. So a lot of times when we're looking to machine quickly and efficiently, we're looking at just pulling a normal company standard that we have and then applying that geometry. So once we have the features here, we're going to go through and we're going to add feeds and speeds and a tool that's standard, and we're going to put together a list of operations. So you can see from the face feature, we added a face mill, then we have some roughing, we have some finishing, some center drills and drills. Those things all reside in a database, and we can edit and modify those, but it allows us to quickly have a company standard for, given this material and this geometry, I'm going to go through and I'm going to use this tool at this feed and speed, this depth of cut, this step over, and all of that stuff is tracked and stored, and then we can leverage it amongst everyone in the team. So when we start talking about SolidWorks CAM standard that comes with your subscription today, this is one example of something that can get you to a toolpath or a program really quickly. And it's primarily set for prismatic geometry like you would see on the screen. When we start talking about SolidWorks CAM Professional, what we start talking about, just like SolidWorks, as you go up, we include everything that was in the standard package, but we add a few extra pieces to it for productivity as an example. So one of the areas that we added was a high-speed machining algorithm, and this gives you the ability to go through and add volume mill toolpaths to this. So you can see here we have an offset on a profile. Now that we have SolidWorks CAM Professional, when we go to our roughing tab, what you'll see is in the dropdown, we now have extended capability through volume mill, as you see here. And so this will kick off the algorithm for volume mill machining by Solichev. And then from here, we're going to go through and update the toolpath, and we have the ability to create a more efficient toolpath with longer tool life, because it's going to control the wear that we have on that tool. So as you can see here, we now have a more automated toolpath to be able to rough that and then go through that process. So upgrading to SolidWorks CAM Professional gives you that as an option. Another option that comes into play is single spindle, single turret lathe. So if we have just a traditional engine lathe and we want to create some basic tool paths to be able to turn this round apart, the process applies the same, where we can run feature recognition. Here you can see in Professional, we have turning, we have 4 and 5 axis pre-positioning, which we'll talk about here in a second. But I can run through, I can extract the machinable features, then I can do my operations. And what you'll see is I can very quickly create a basic turning operation. Now, it is important to understand when we start talking about SolidWorks CAM Professional and turning, we are 100% talking about traditional engine lathe, single spindle, single turret. We're not talking about sinking. We're not talking about Milturn. It's just basic turning. Again, if we're talking in that tool room or fixture design, we have the ability to put that in here and away we go. And then the last area that comes into this too is 3+2 indexing. That gives us the ability to take those prismatic parts that we talked about before and then be able to pre-position them on a 4 or 5 axis machine. We are doing nothing simultaneous. We are just tipping over the X, Y, Z position, or the A and C or A and B, depending upon your machine. We're flipping those into that position, doing the rotation and index, and then we can do the basic machine. So if we had 4 of these on a horizontal tombstone, we can machine all 4 with SolidWorks CAM Professional, but it's all going to be moved to that perpendicular face, then do the machining. Okay, we start talking shop floor programmer. This is the other one that gets included if you have cloud services added to your license. This is the other one that is just part of it, and it does a lot of the same things that you would see in SolidWorks CAM standard with additional components to it. But the one thing that it does do that's a little bit different is it does not run inside the SolidWorks Windows interface. So the first question we generally get is, because it does not run inside of SolidWorks, how are version updates and changes going to happen? And so I'll have a video here we'll go through this process. So here's a part we have programmed in Shop Floor Programmer. And you can see we have pockets and bosses and everything's programmed. And it looks all hunky-dory and fine the way that it should. But inevitably, we end up having scenarios where the geometry changes. So how is that handled? Well, it's handled like any other solution that's out there. We come back to SolidWorks, we make a change, maybe change those angles on those pockets or whatever the engineering group is going to do. It's hard to tell sometimes what they come up with. So we'll make a design change, and then we simply just save this again to the platform. Once it's saved in the platform, it's going to take care of all of the back end stuff. So as a user, I'm just going to hit save here. It'll run through its automation routine, make sure everything that's in check. We can revision control it. So if you wanted to have a revision A or a revision B, we can handle those independently in the machining application. So we reflect both. But simply once that's been saved, we do a refresh. Just like if you were going to do a control Q in SolidWorks, the geometry is going to update, and then we simply rebuild the toolpaths, and all of that syncing is going to work the way that it should. So when we start talking about revisions and updates and syncing, what happens if it's not in the SolidWorks user interface, it's all good. It behaves the way that it's supposed to. So here, everything is going to update. The toolpaths are going to change, and then we could simply just rerun this and post it back out, and life's good and Bob's your uncle. So for any of the advanced solutions, whether it be robotics or machining or virtual factory, we are linking and making sure that the design data that comes from SolidWorks or any CAD system has the ability to be synced and updated through the platform managing all of the goodies. Another thing that comes into this is nesting. So if you have parts or weldments or sheet metal, we have the ability to do that same save to the platform and then look at an assembly, automatically pick the quantities, sort by thickness and material type, be able to put in the sheet size the way that you want, real contour or bounding box. And then from here, we're going to automatically create each sheet nested out as it should be. So you can see over on the left, there's all the sheets required to make that weldment. And then from here, we have the ability to go through, save those, store them, and then create toolpaths for them as well. So if we were going to do laser water jet plasma, we can throw those toolpaths on, as you'll see here. I can go through and I can click the part, pick the laser head. I can do kerf. If I'm doing like a plasma as an example, I can define what the kerf's going to be. Pick all the profiles. I can do tabs on that if I want to, or micro joints, depending upon what era you came from for programming machine or lasers. And then from here, we have the ability to go through, simulate that, validate it, verify it, and away we go. So if you're looking to get into, basic nesting components and things like that, where I want to be able to just run this and then have it all tracked and stored, we have the ability to do that with Shop Floor Programmer as one option. Another benefit that happens with our advanced machining is any of our platform capability has machine simulation set into it. So if we have the model of the machine set up for you with the kinematics and the movement and the jaws and the vise and all that good stuff, you're working and programming within the environment of that machine. So as I look at this, I have this DN machine here. I have a rotary table, I have a vise. And then as I program this, I'm just programming the part and the software is solving that simulation for me. So what you'll see here in a second is I'm doing 3+2 machining, but I'm able to simulate all of that, validate it and verify it, as well as check for collisions to ensure that I'm programming the right thing. So here you can see as it's rotating down, coming over, doing some drilling, I'm checking and validating everything within the environment. I'm not programming it, sending it out to a simulation, and then coming back. I'm programming directly within the simulation environment, which saves time and speeds up the process. Another area that comes into play sometimes that people may want is manufacturability checker. And this manufacturability checker is a little bit different than DFM Express. Sorry, I got to move my mouse there. This does some different things. One of the things that it does is it will look at the CAD model and determine whether it's a better fit for additive or subtractive. So we can take a look at geometry and see how it's going to fit and then give feedback on whether this thing is going to be more challenging if my end goal is to do subtractive, and maybe I need to change my design to make that better. Another thing that comes up with this too, because we have access to those machines in our simulation, I can go through and I can say, will this part fit in this CNC machine? Is it reachable from those areas? And I have the ability to load that machine and then do what if to see if it's going to fit. Here's an example of comparing that comes with that as well. So it's a little bit more spec'd for additive and subtractive manufacturability checker, but it's also spec'd more of, can I fit this part in the machine physically? So it's a little bit different than DFM. It's more of an augments what DFM does to make life a little bit better for people that need that. When we start going up a little bit, this is where we get into milling professional. And from shop floor programmer, there's sort of two paths in the professional version. There's milling professional or turning professional. And milling professional is for people that are primarily going to be a mill shop. Turning professionals for people that are going to be primarily a turning shop. And then if you need milling and turning together, Milturn Premium covers everything that we have for machining. So I'm going to show a couple examples on the Milling Pro. And then when we get to the turning side, I'll talk about it, but I'll show some examples in Milturn Premium. So one of the benefits of any of the professional tools is I talked about in SolidWorks CAM, we have that rules-based standardization. We take that exact same concept and feature recognition, literally the exact same feature recognition, and then we apply rules, but instead of a database, we have the ability to create more of a template. And then from that template, we have the ability to run full automatic mode or interactive. So I have this part set up in a machine. I'm going to go grab a know-how template, which is my foundation. So instead of a database, it's going to be pulled from there. And then if I were to run automatic, it'll just go find everything it can through feature recognition, or for advanced things like a mold or multi-axis, I can walk through this setup of interactive where it's going to say, okay, I need some geometry. I think I know where it's at, but you want to define it. So here I can go through and say, okay, I want this to be my new boundary. And then which machining direction do you want? Because I'm doing multi-axis. Milling Professional gives you a 3 to 5 converter. So you can do 5-axis tool paths, not just 3+2. And then in here, I'm going to define some limit lines of where I want the geometry to go. And the key here is I have the ability to walk through it. So I can either just say, go run it and find what you can, or I have the ability to pick which pieces of the operation I want. So I have full control on how this is going to behave. So here you can see in this mold, I have my standard roughing, finishing, processing, everything that comes across here. And I'm using that from one part to the next part, to the next part, to the next part, regardless of what the change is going to be. And I have the ability to run an interactive mode. Another area that comes into play when we start talking milling professional is some advanced 3-axis toolpaths. And I'll show you an example of what that is, because sometimes it's a little confusing when people say that. So when we start talking about, our shop floor programmer, we can do 3-axis. But when we go to milling professional, we have more specific things like 4-axis. We have 3 to 5 converter, where I can do through a point, through a curve, from an extension, normal to face, on a lot of geometry. But then I have extended specialty operations for certain areas, including 5-axis deburring if I want to do that. So when we start talking about the geometry here and doing more advanced things, we're talking about specializing a little bit for things such as molds. So here's an example of some of the areas we would go through, some of the passes that we have, and then we have the 3 to 5 converter, which gives us the ability to do that. I would call it more like a traditional 5-axis you would see, where you can put a point out there in space. And then on top of it, we have this intermediate stock where we can see all that in real time. So I don't have to watch the toolpath run. I can just click on a button and it'll show me the result. What's coming in, what's going out, where are we gouging, what's the remaining material. So if I'm a person that's in a hurry and I don't want to watch the toolpath run, I can just hit those buttons and do the simulation on the fly, and away we go. We have high-speed machining with our advanced machining. What we do is a little bit different. So in SolidWorks CAM, we have ModuleWorks. When we start talking about our high-speed machining with Milling Professional, What we're talking about is concentric, and we call it adaptive concentric because it looks at the geometry and it'll optimize the tool path for air cutting depending upon the geometry shape. So if I were cutting around the outside of this part, the tool path would look a little more adaptive if you're used to seeing other CAM solutions out there, to where we're not going to do a bunch of air moves. If it's going to be more of a pocket like on the inside, it's going to look a little bit more like a volume mill tool path that you would see in SolidWorks CAM, because we want to reduce the profile contouring on it. So the high-speed machining we call adaptive concentric, because in certain geometry, it'll look adaptive. In other pieces, it'll look more concentric or volumetric. So we have the ability to set those. And then we have a bunch of specifications that go. So if we're running our high-speed machining, we can say, well, in a pocket, I want to run it different than if I want to run it out. We have full control over those. We can do zigzag back and forth. We can do our optimized or maximum or minimum clearance for how far it's going to come up and move when it runs that. And we'll get to the end here, and then we'll go ahead and hit play or display. So you can see it's going to go through and it's looking at the geometry, and then it's coming back and creating an optimized cut. It's also looking at the intermediate stock before it. So if a lot of that material was removed ahead of it, it's only going to create a tool path that would look at the optimized cutting conditions, so we're not cutting lots of air in that process. So there's lots of advanced capability that comes into this, which really helps out programming to be able to make that work the way we want. And from there, we'll jump over to turning professional. Now, in this one, I'm going to talk about it, and then I'll show some examples in Milturn Premium. For turning, we have the same know-how. So imagine your templatization that you had for milling professional to be able to run that automation and go through it. The benefit of the rules-based machining with our high-end stuff is we can do it on 5-axis, we can do it on 3-axis, we can do it on prismatic, we can do it on lathes. You have the ability to set up templates and automation for pretty much anything that you want to do. Where the difference between Turning Pro and Milturn Premium is, when we start talking about Turning Professional, we're talking about prismatic movements with a lathe or a Milturn or a Swiss, like you see on the part on here, where we have a bunch of flats, we have some conical shapes, we have some holes that are indexed around. Those features are all prismatic. So in that instance, Turning Professional, we could run a Swiss machine in Turning Professional on prismatic parts. Where it becomes non-prismatic, then it would go to Milturn Premium. So imagine you had a bearing and you had an oil groove that went on the inside of that housing, but it sort of made like a curve around the inside of the surface with a live tool. That becomes non-prismatic because we're indexing the spindle and the live tool and the turret at the right location in sync. That makes it non-prismatic. So that's really the difference between the two. But we have an unlimited number of axes we can program in Turning Professional. Just keep in mind, everything stays at this prismatic part that you see out here on the screen. So if we rotate this around, you can see it's a little bit more prismatic. We have full syncing capability on this as well, and collision detection of any of the tools, holders, that stuff. We can run live tooling, but we're going to be programming for prismatic shapes. Okay, when we get to Milturn Premium, this includes everything that we have for machining below, plus a few extra things here, including robot machining and robot machine tending. So if you wanted to program the robot to tend parts, we can do that in Milturn Premium. We can also do it in our robot programmer capability as well, but we're only talking about machining today. So we're going to talk multi-axis turning, surface versus prismatic. I already explained that previously, but here's an example of Milturn. So we have the rest of the machine hidden here so you can see what's going on. But essentially in this scenario, we're going to go through, we're going to do a machine on that piece. And you can see that we can sync upper turret, lower turret, main spindle, sub spindle. We can do handoffs. The big key here is the operation tree on the left. What you see is what you get. So if I put machine instructions in over there to be able to program it, that's what you're going to see, and that's how it's going to function. Let me jump ahead here just a little bit. So you can see in here in our rough turning, here's our connector to be able to go between the two. And we have the ability to say, hey, I want my corrector to be in this position. I want those components to go together. And then in my rough turning, I have the ability to create that. So as we're going through, let me jump ahead to the simulation. I apologize here. Let me back up just a hair. Okay. So when we go through and start running this, we are machining, just like you saw with SolidWorks CAM Pro on a single spindle, single turret. Here, we're invoking everything together and then checking for collision. So we're going through, we're facing with the top turret, and then we're doing pinch turning here on the bottom. And then once we have that, we have the ability to move things out of the way and sync. And then if we had a sub spindle come up, we can program that movement of the sub spindle. The key here is we're not doing the black box post processor thing where there's this black box at the end and you just hope that the G code comes out correct. What you see is what you get. How it behaves here is how it's going to behave in the machine. So that should give an idea of, we start talking about Milturn. What we're talking about is in Pro or Premium, we have the ability to sync them, see them, verify them, make sure they work. The only difference we run into here is, I'll pause it right here. See this oil groove here? This would make it Milturn, or this would make it turning professional because it's a straight line. If this curve went to a helix all the way around the part, then that would become Milturn Premium because we're going to sync the spindle with the live tool and the turret at the same time. When we start talking about advanced capability in our milling, then we unlock all of the capabilities that we have for being able to create advanced tool paths. This is an example of a barrel cutter that comes in any of them, but the ability to have specialized operations at the bottom for tube porting, for rotors and blades, for outside profiles, specialty things you would see in aerospace. We have the ability to program all of that and have special operations for it to make it easier to select and then build templates off of that. Here's an example of doing a barrel cutter on that face. And the key here is I showed you turning with machine simulation. Here's an example of advanced milling with machine simulation to be able to guide that barrel cutter down that face and create the smooth surface that we want. So we'll go through and we'll run it. And here you can see we're able to analyze and verify where that barrel is going to cut down along that path to make sure that it clears where we need to be and get the finish that we're looking for. And I believe when we go ahead and run it, we can simulate it. We do have G-code validation as a higher end add-on if you want. And what you see is what you get. And this is sort of the point of this video. So the key here is what we see and validate in the software is exactly what we see when it comes out at the end. For Swiss turning, we have the ability to set up that machine. Again, the whole goal of this is we're programming in the environment of that machine. So here we have it set up for front turret, rear turret, side mount turret, and then we're programming within that environment. And we're able to simulate and validate this as well. So we'll zoom in and we'll take a look. You can see we can build out the tools with all the detail you want, or we can keep the tools simple. It's up to you, depending upon how you want it to look. But we build this environment. We build the kinematics from CAD geometry. We're not doing STLs or any other crazy stuff. We take the CAD models or geometry that's here. Then we put them in. We define what they are and how they're going to function. And then from here, we can simulate and validate against. So I'm going to jump ahead here just a little bit. You guys have all seen CNC machines before. Let me jump to here. So here you can see we're machining on both spindles at the same time. This stock is moving the way that it's supposed to be moving, and we're simultaneously programming everything that's running, just like you would see it in the real world. You can see that the front part and back part are being turned. And then from here, we can do the grab operations, move, drop, whatever you want it to do. But we'll let it run. And you can see the validation verification is exactly what you want it to be. So when we go out and run in the machine, we know exactly how it's going to behave. And here's some prismatic stuff that you can see on this one. And there is the finished part that we're going to look at from this end. But the machining, the simulation, the validation, and the verification all run together. So now we're going to turn that off. And then they're going to do a part handoff to the other spindle if you want. And away you go. And then the last one, we've seen this start to become more popular. We have the ability to do machining with a robot. So imagine creating your 5-axis tool paths like you're used to seeing. And then instead of using a 5-axis machine, we just slap a end mill on a robot. And then from here, we run that same tool path and we let the software figure out the robot kinematics and how it's going to move. Just like if you were doing arc welding with Robot Programmer Standard, we're just throwing the robot in here, putting a machining head on it, and then we have the ability to machine. We can also laser water jet plasma with the robot as well. We can do machine tending from this, so we have full interop between them. The advantage of our advanced manufacturing toolpaths or advanced manufacturing suite is I can jump between robot programming and arc welding and pick and place into machining and do machine tending or machining with a robot. This is an example of a scanned in statue. It was scanned in, converted to surfaces, and then from here, we're actually doing the machining and the toolpath on it, and we're letting the software figure out the kinematics in the joint. Again, the key here is this robot exists in the environment that I'm programming in. I'm not programming a toolpath and then sending it out to another application to verify it. That robot is the exact same robot we would use for arc welding. We just put a different head on it. And now we're using it in machining, and away we go. So if you're interested in like expanding or making your shop floor more universal to where I have a robot sitting in an area, sometimes maybe I want to cut flashing off of a fiberglass hull with it, or next week I want to do a mold, or the week after that I want to use that for welding. You have the ability for that to be supported through multiple different processes, and that's why it falls into our advanced machining category. And with that, we're at the end of our presentation here.